This is GATE 2017 set 2 electrical question number 53. Two generating units rated 300 and 400 megawatt have governor speed regulation 6% and 4% respectively from no load to full load. Both the generating units are operating in parallel to share a 600 megawatt load. Assuming free governor action, load shared by larger unit is asked in megawatts. For NPTEL reference, you can refer to lecture 24 Automatic Generation Control of the NPTEL course Power System Generation, Transmission and Distribution by Professor D.P. Kothari, Department of Electrical Engineering, IIT Delhi. So now we are coming to the useful data. The power transfer between two machines connected in parallel can only happen when they are operating at the same frequency. As loading on a generator is increased, the speed is decreased because the governors are slow and their mechanical devices. Also, the generation cannot increase instantly as load can change suddenly. These are electrical loads and they can change abruptly, but the mechanical generation cannot be increased and matched with the load that quickly. Hence, there is a droop observed in the generator characteristics. Speed, that is the analogous to frequency, has a variation with the variation in power generated by the generator. As the loading on the generator PL is increased, frequency decreases. Two machines, two different characteristics. And by similar triangle concept for machine 1, write this no load length minus F. So this arm divided by no load length minus FL1. What we are trying to say, this by this triangle is same as this by this. Similarly, for the machine 2, this small length by this is equal to this by this. So same by similar triangle concept. So this 3 and 2 holds like this, and after that the load is shared. So P1, that is generated by 1, and P2 generated by machine 2 should match with the load demand. So with these three equations we can find the F and the values of P1 and P2, that is how much load each machine is sharing. So since there is a droop with the change in loading condition, this regulation, that is the change in frequency, is also termed as frequency regulation, is given by no load frequency minus full load frequency divided by no load frequency, that is with respect to no load we are taking into 100%. So this is the percentage speed regulation or frequency regulation. Coming to the solution, the frequency versus the electrical power generated curve for the two machines are like this with their droop characteristics. And since no load is the reference, because in the question it is given from no load to full load, so considering no load to be same for both the machines, no load frequency, and this as reference, this is the higher rating machine which has more capability to generate more power at full load. So this is machine 1 and this is machine 2. Now they have to share a total load of 600. So this is, I can say P2, this is P1, and P1 plus P2 they are given 600. So this is in megawatts. So 600 they need to share. And if the operating frequency is F, then I can write F no load. So this is full load minus F full load 1, and I can write F no load because it is same for both the machines. So F no load minus F full load 1 by F no load minus F equal to 400 divided by P1. Similarly, F no load minus F full load 2 divided by F no load minus F equal to 300 by P2. FNL minus FFL. So it is given the question that this is 6% and this is 4%. So FFL1 equal to FNL into 1 minus 0.4, because 4% speed regulation with respect to no load. So full load frequency for first machine is like this, and full load frequency for second machine, because the 6%, so we can write minus 0.06. These are another two equations which will help us write the value of FFL1, FFL2 in terms of FNL. FNL minus FFL1 will give me 0.04 FNL divided by FNL minus F, and this will give me 0.06 FNL divided by FNL minus F. Dividing these two, we get 400 by 300 into P2 by P1 equal to 0.04 divide 0.06. So I can write P2 by P1 equal to half, or from here I can now write 3P2 equal to 600, which means P2 is 200 and P1 is 2 times P2, which is equal to 400. So P2 is 200 megawatts and P1 is 400 megawatts. So this will be the answer. Since it is asked the larger unit, which is having more full load generation capability, this one, that is machine 1, is generating 400, that is operating at full load. So is 400 megawatts. Thank you.